Yeah, hi everyone. My name is Chandan, and welcome back to my channel Energy and Environment Education. Friends, this is chapter 2.3 Steam System, and this is part C of this chapter. I have divided the entire chapter into different parts. Part A and Part B of this chapter has been uploaded in my channel. You can go to the channel Energy and Environment Education. There you will find videos on part A and part B of this chapter. Also you'll find different videos on on different chapters that I've uploaded on in this channel. So all these videos are equally important, and this will help you to prepare you for your exam if you're preparing for the energy auditor exam or energy manager exam for this year or in the coming years. And also equally important for the engineers who want to understand this subject, and if they want to build career in energy domain, for them also these videos can be equally important, friends. So please go through the videos that I have posted on my channel, and hopefully these videos will help you in preparing for your exam, also building a career, friends. So today's video will be on part C of this chapter, which is also important, and hopefully this video will help you prepare your exam, friends. So let's start the video, part C. So before we begin, let's the content first. In the first part, I'm going to explain you the stream distribution system, which already have been explained in the part B, and it is continuing from the last video on part B that I have made. Also, I'll be explaining about the efficient steam utilization part of this chapter. So those even both the parts are equally important, and a lot of questions you can expect in the exam from these two parts, friends. So let's start the video with these two parts, friends. So continuing from the part B, you have some numericals on the Eastern distribution system. Also, this is one of the as a numerical you can say, or concept you can say, which is very much important for your exam. As an example given here of effect of air in steam system. Like suppose if the steam system is not so pure, there is a mixture of air inside the steam system, and what will be impact of it. So that type of question also can be asked to explain with the help of an example in the exam, friends. So if 20% of air is entrained in a steam system at 5 kg per centimeter square, then the effect of air will be as follows. So this is going to be the effect of air if there if the effect of air on the steam, or if there will be 20% air is entered in a steam system, friends. So steam quality is like suppose 80% steam is there and 20% of air is there. So with this pressure there will be impact on a pressure, you can see here. So calculation is 80% steam is there, so if it is 5 kg per centimeter square of pressure is there, so 80% which means 0.80 into 5 plus 20% of air is there, so 0.20 into 5, so you get 4 kg per centimeter square and plus 1 kg per centimeter square. This means entire 5 kg per centimeter square of the pressure is now broken into two halves. I'm not equal to half. It is 4 kg per centimeter square plus 1 kg per centimeter square. This means now the effect of the pressure will reduce. So if there is temperature, I mean if there is a mixture of air inside the steam system, the pressure ultimately gets reduced. So if it is you are producing at a 5 kg centimeter square, but ultimately you are getting only the 4 kg per centimeter square of pressure, not the 5 kg as a whole. 1 kg will be wasted. Same way you can see a temperature of steam at 5 kg centimeter square should be 158 degrees centigrade, but now since there is a mixture of air around 20%, so now you are getting only 152 degrees centigrade. So there will be drop in the temperature also and the pressure also, friends. You will not get the desired temperature, you will not get the desired pressure of the steam, friends. So this is the effect of air in a steam system, and this can be explained in the exam with the help of this example, friends. In the exam also they can get questions on like why there's need of steam pipe installation, or what is the importance of steam pipe installation. For that also this is very much important question, or you can say important part of the chapter, you can say. So you must understand this concept, and also the remember the different points that are highlighted here, friends. The installation of steam conveying pipes and the steam consuming equipment is very essential to retard the flow of heat from the steam to the environment. Broadly, the purpose of steam pipe installation is follows. These are five main important reasons why you should go for the steam pipe installation. The first thing is the conservation of energy. Conserve energy by reducing heat loss. So if you have a proper steam pipe installation, with that you will be able to conserve energy. There will not be any heat loss from the pipe. Facilitate temperature control of a process. So whatever temperature you desire, you want to have of the steam, you will get it. if the steam is insulated, I mean steam pipe is insulated. If the pipe is not insulated, then there will be heat loss and you will not be able to get the desired temperature of the steam, friends. Prevent condensation of the steam. This is also important point. With the help of proper installation, there will not be any condensation of the steam going on. Prevent or reduce damage to pipe from exposure to fire or corrosive atmosphere. So this is also an important point where the installation of steam pipe is important. Control surface temperature for personal protection and comfort. Also, people are working there, and in that case, also installation of pipe is very much important because this will not create any sort of hazards, friends, in the plant area. So these are different points that you should understand, you should remember, and also be able to explain in the exam. If they ask you to name the points or name the important aspects of steam pipe installation, and also briefly explain them, so you can understand this thing and can be able to explain in the exam, friends, if the question may be asked to you. So this is an important table, friends, that you should understand what is effect of insulation on steam pipes. You can see here how the insulation impacts the steam pipe. I mean, see, you can see here the radiation losses going on if it is insulated and if it is uninsulated. So both the aspects are given here. For example, pipe size is ½ inch, and then economic thickness of the insulation is given here 50 mm. In that case, if it is insulated, so you will have this much of amount of heat loss or radiation losses going on. But if it is uninsulated, in that case you will have 692. So you can see the difference here between the insulated pipe and the uninsulated pipes. You will have a lot of more amount of energy losses going on, radiation losses going on if the pipe is not insulated. Likewise, if you see here, if the size of the pipe increases, this the losses also goes increasing. But you see here, if you compare the insulated with the uninsulated part, so if you increase the pipe size, also thickness of insulation increases, but you see the difference between the insulated and the uninsulated part. So if you have, like, suppose 2-inch pipe where the atomic insulation thickness is of 25 mm, but you see here the insulated pipe will have 243 kilowatt per mm per meter is radiation losses, but in this case if it is uninsulated it will have 1820. Likewise, you can see here, if it is 12-inch pipe and the economic insulation thickness is 50, if it is insulated you will have 588 kilowatt per m of the radiation losses, but if it is uninsulated you will have 7614. So you can see the number of times the heat loss or radiation loss increases if the pipe is uninsulated. For that reason only you have to have the proper installation of pipe, and this will help you to minimize the radiation losses or the heat losses ongoing in the pipe area, friends. So this is an important point that you should understand. This is also important explanation here which can be used to explain the effect of insulation on steam pipes, friends. Now this is another important point where it is explained how much how efficiently the steam is utilized, friends. Basically, if you consider fuel that you feed inside the boiler and the steam that is used at the product end, you'll see a vast difference there. I mean, there is ongoing heat losses inside different areas where the steam is passing through. Like, suppose you're feeding the fuel 100% efficiency, you expect to have in the boiler, but actually what happens, there is a 20% loss of heat in the boiler section itself, friends. So 100% if you feed the fuel and you expect to have 100% efficiency, that's not exactly happening here. So 20% losses is going on inside the boiler now. So you can understand that around the 80% efficiency will have in the boiler. Now if you move on in the steam mains, that is steam pipes, here also at least 5% of heat loss is going on. So ultimately, if it is 80% at the boiler, more 5% is reduced. Now you have 75% of steam efficiency here, friends. Or now if you see the process, when it enters the process area, there are also steam loss is going on, I mean heat loss is going on, some part of it. So you can expect to have around 25% of steam loss there itself. So out of 75%, 25% is almost loss, and actually in the product where the steam is utilized for the manufacturing process, so in that case there around 35% only is utilized. So if you see the efficiency steam utilization, so around 35% of the steam is actually utilized. Now again, other parts are lost. So you can consider how important is to have a better steam system, such that you have at least 35% of utilization of the steam. And this is when the steam distribution system is properly designed, and you can expect to have the losses if it is not properly designed, friends. So that's why it is very much important to design the entire steam distribution system in a better way, friends, such that at least you can have a better steam utilization or efficient steam utilization, friends. Now comes the thermocompressor. This is an important area when in exam you can be asked to briefly explain this thermocompressor all about. So in different exams it has been asked to briefly explain this part. The working principle of the thermocompressor also asked in the exam. So this picture you must understand and also the explanation you must understand. I'm not going to explain you in detail here. This is a very easy explanation given here in the chapter itself. You can go to the book, you can go to the chapter, this part of it, and you can understand this entire explanation. Otherwise, just to give a know-how of this thermocompressor, basically what's happening here in many of the steam utilization equipment where condensate comes out of a high pressure, a major portion of it flashes into a low pressure steam which goes wasted. So basically, when there is a loss of pressure inside the condensate, using a thermocompressor becomes feasible to compress this low pressure steam to a high pressure steam and reuse it as a medium pressure steam in the process. So sometimes what happens, the condensate coming out is it's not used properly. So what happens, the low pressure steam can be mixed with the high pressure steam in the thermal compressor and can be used as a medium pressure steam in any process or any area you want to have it. Thermal compressor is helping you to mix the low pressure steam with the high pressure steam, and as a whole you can get a medium pressure steam, friends. So the low pressure steam is basically utilized here with the help of thermal compressor. This is the entire concept of thermocompressor. You can read it, you can understand it, how thermocompressor is helping to utilize the low pressure steam which is coming out of the process, friends. And here are a few advantages of thermocompressor which may be asked in the exam to explain or briefly to list out the few advantages of thermocompressors. So at least you must remember five of them. So you can see here the advantages of thermocompressor. The first one is the no condensation losses takes place. Thermal efficiency of the system is extremely high. Entrainment of low pressure steam results in substantial savings. So you are utilizing the low pressure here in the thermocompressor. No moving parts and hence maintenance needs are minimal. No major operation charges, low space requirement, insensitive to fouling, high operating reliability. So these are the important points that you must understand, you must remember as an advantage of thermocompressor. So if they ask you in the exam to explain it, you must be able to do it, friends. So here's another important point, the dryer. They may ask you in the exam also to briefly explain the term dryer, or you can see the working principle of dryer, or what dryer is all about. So in that also you must understand this part and also be able to explain it. It's a very easy explanation given here. Basically what's happening here is you are using this entire concept to basically dry the material. So you basically what's happening here, you need to remove the water content from the any material. So drying is a process by which a liquid, commonly water, is removed from a material, and this process is called the drying. This is usually achieved by applying heat, typically steam. So what you are doing here, you are applying the steam across the material that you want to dry. So with the help of steam, what happens, the liquid part inside the material is gets evaporated, and as such the material gets dried. This is the entire concept of the dryer, friends. So in the case of dryer also, friend, a lot of energy is used, and so basically the drying energy requirement is needed to evaporate the water. So actually what's happening here, as I said in the last slide, basically what is happening here, you are drying the material, and in that case the water content in the material gets evaporated. So basically, like suppose steam is utilized to dry the equipment or material as such. In that case, the any water content inside that material will be evaporated with the help of steam. Clearly, this depends on the amount of water being evaporated. In most cases, the product material, the carrier gas, and the equipment also need to be hot. So the total energy required includes. So basically, the energy that is utilized in drying any material is given here, friends. Heat leaving the dryer and exhaust flow. This includes the latent heat of the water evaporated, but the sensitive heat of the hot gas can also be significant. So there is a lot of heat loss. We can say heat utilized as a latent heat as well as a sensible heat, friends. Heat loss from the equipment and ducting also is there. So heat loss is also going on from the equipment as well as the ducting part. However, good insertion, there is always some heat loss. So heat loss is also from the ducting part, from the equipment part of the dryer. Heat leaving the dryer as hot product, that also is a part of heat loss going on. Motive power or fans if it is used, and conveyors if it is used. So these are some of the areas in the dryer where the heat loss occurs, and that has to be really taken care while using the dryer. So if you are fulfilling your requirement of drying the material, that is one aspect, but also you need to understand the energy losses going on when you utilize the dryer, friends, for drying the any material, friends. So these are two aspects that you should understand while using this dryer. So this is the end of the part C, friends, and we'll continue with the part D again. So I hope these concepts, whatever I have given you, and the points that I've shared you in this particular video in part C is going to be useful for you while preparing for the exam, and you will have a better understanding of the chapter, friends. Part D will be coming soon, and also will upload in in few days time. So please be connected with me such that you can know the entire chapter part by part, friends. So that's all for today, friends. I hope you must have enjoyed the video, and before you leave, please do subscribe the channel if not yet, and please do go through my different videos that I have posted on this channel. This will help you to prepare for your examination. This is part C that I have concluded. Also will come following with the different parts of the chapter, and likewise I have also prepared different videos on different chapters in and I posted in this channel, so you can go through all the chapters. That will be equally important for you to understand while you prepare for exam, friends. So this is my YouTube channel, Energy Environment Education. Please do subscribe it, and it's not take too much time for you, and also it's a free of cost. It will only take few seconds of you to subscribe the channel. So please do subscribe my channel to motivate me to prepare more such videos in coming days. Also please press the bell icon so that you get the instant notification as soon as I post a new video. And please do connect with me on this number. This is mobile number. It's also my WhatsApp number. You can write to me anything if you feedback, and if you have any inputs if you want from my side, any thoughts you have for regarding the video content or any presentation content. So you can please write to me. This will be really beneficial for me to improve my content wise in coming days, friends. And also please you can also use my email ID to share your inputs, thoughts, and whatever you have in your mind, friends. So please be connected. Do watch my all these videos that I have posted in different in the channel concerned, and please be connected with me for coming videos also, friends. So that's all for today, and I hope you must have enjoyed the video. You must have liked the content. Also please share it with your friends and colleagues, whoever you think it is beneficial for them. Also if you are engineering student, for that purpose also it can be beneficial. Also if you are looking forward to make career in energy domain, for those people also it's very important to understand these concepts which I have shared in different videos in this channel, friends. So that's all for today, and we'll meet in a new video in coming days, friends.